Okay, next is question number 18 from the May 2023 Physics Unit 1 paper. Okay, so here the question says, okay, at first you can see this is an asterisk question. This is star marked question. A student inflates a balloon. Okay, she uses a peg to keep the balloon closed. Okay, so you can see in the figure. So the student uses a peg to keep the balloon closed. Okay, she then attaches a straw to the balloon using sticky tape. Okay, a straw is connected uh, to connect what, the sticky tape. A straw has been attached to the balloon using the sticky tape. Okay, she passes a string through the straw and pulls the string tied as shown. You can see everything in the figure. Okay, the student removes the peg and air leaves the balloon. Okay, the velocity of the balloon increases from 0 to a maximum. Initially the velocity of the balloon was 0, and then it accelerated and it reached a maximum speed. Okay, so maximum speed, I'm sure that you can figure it out. Basically this is the terminal velocity. Okay, now we need to explain here how Newton's three laws of motion apply to the motion of the balloon during this time. Okay, so using the three laws of Newton's motion, law of motion. Okay, we need to explain how how the motion of the balloon can be described using the Newton's three laws of motion. Okay, so at first what we can start with, just consider what is happening initially at the beginning. The student removes the peg. As the student removes the peg, what will happen? The air particles within the balloon was in pressurized situation, isn't it? So due to that pressure, what will happen? The air particles will be pushed outward, right? They will be pushed in the backward direction by the what? Inner air particles. Okay, so as the air particles are pushed out in the backward direction from the balloon, what will happen? According to Newton's third law, due to that pushing force, the outcoming air particles will apply a reaction force in the forward direction on the balloon. Okay, this is the first case. So we can write the first starting. This is just beginning. In the beginning, what happens? The air particles are pushed out of the balloon in the backward direction, right? Okay, so from Newton's third law, so from Newton's third law, motion, what we can say? The air particles will apply the outcoming, we can say outcoming, the outcoming air particles will apply what? Reaction force on the balloon towards the forward direction, right? Towards the forward direction. Fine. This is the first 2 points we got. Next, what happens next? Okay, so there is a forward reaction force, it's acting on the balloon in the forward direction. Okay, fine. So due to that force, what happens? This forward force, it's basically what? Greater than the resistive force initially, right? It's greater than the resistive force. That's why it is what? The balloon is accelerating in the forward direction. Okay, and it is accelerating in the forward direction because the resultant force in the forward direction. So according to Newton's second law of motion, we know that the acceleration will be happening towards the direction of the resultant force, right? So that's what we can write here. We can say that the forward, okay, it should be forward reaction force is greater than what? Than the resistive forces acting on the balloon. Okay, so resultant force is in the forward direction, so resultant force is towards the forward direction. Okay, hence according to Newton's what? Which law? Second law. According to Newton's second law of motion, what we can say? According to Newton's second law of motion, the balloon accelerates in the towards the forward direction. Because the resultant force is acting in the forward direction. We got so far 4 points. The last two. What happens next? As the balloon is accelerating, its speed increases. As the speed increases, the resistive forces acting on the balloon increases, and gradually it balances out the what? Forward reaction force. Okay, so when the forward reaction force becomes equal to the resistive forces, that time it reaches what? It reaches equilibrium. It reaches equilibrium position, so no resultant force, hence what? The balloon moves with constant speed. That's what according to Newton's first law of motion. A stationary object will remain stationary, and an object in an object in motion will continue its motion at constant speed unless a resultant force is applied. That's what Newton's first law of motion says, right? So what we will say here, how it has reached maximum speed. Okay, as the balloon what? Accelerates, its speed increases, so resistive force acting resistive forces. Remember, this is asterisk type question, so in that case they will definitely check out your grammatical mistakes or any mistakes in the what? Sentence structure. Okay, so you should be aware of that. So as the balloon accelerates, its speed increases, so resistive forces acting on it what? Increases and becomes what? Becomes equal to what? Forward reaction force. Fine. So resultant force acting on the balloon becomes 0 Newton. Okay, the resultant force acting on the balloon becomes 0 Newton. Therefore from Newton's first law of motion. First law of motion, what we can say? The balloon, okay, we can write it here. The balloon will what? Keep moving with the maximum, with the constant speed, constant maximum speed. Okay, maximum speed. That's it. That's the exact 6 points for this asterisk question. That is question number 18, and that's all about this question. Fine.